Right, here's a question on SHM with elastic strings. Edx M3 Jun 2011, question 7. So there's the whole question. Pause the video as usual and take your time to read through it and make some notes perhaps. Here's a diagram for the first part then. It's a light elastic string stretched between A and B. O is the center, and the distance A to B is 2. So this is 1 meter to O, and OB is another 1 meter. First thing we've got to do is show that the tension in BP is 2/7 of 3 minus 10x. Well, the first thing to write there then is the extension. The extension of BP is going to be 0.3 minus x, because the extension of BO or OB was 0.3. So if you moved x towards B, the extension of that part of that portion, that string, is now 0.3 minus x. And the extension of A to P, it was extended at 0.3 and it was AO. Putting it across another distance x means the extension now is 0.3 plus x for AP. So for the tension of BP, which I'm calling T1, lambda is 2, L is 0.7, or 0.3 minus x. And that's the same as they've got if I just rewrite it as 2/7 of 3 minus 10x. 3 minus 10x. Right. Now what's happened there? 1 moment. Just need to tidy that up. Right. 2/7 of bracket 3 minus 10x. That's BP tension, and we've got to find the tension in AP. Well, working it out in exactly the same way then, from the extension of AP, for AP, T2 works out to be, and you can verify this, it works out to be 2/0.7, or 2/7, into 3 plus 10x. Very similar working, almost identical, to get the tension in the BP portion. So now we're all set up to carry on and get into the SHM part. Let's do that. And this says show that P performs simple harmonic motion with period 2 pi. Okay. So what we've got here, if I just move that over a bit, is there's P. Here's the equilibrium position, and here's X. X double dot will be measured that way, will be positive that way. T1 was on this side, there's the particle P. T1 was on this side, and T2 was on that side. So the equation of motion for P is T1 minus T2 equals M, which is 0.5 x double dot, that's right. So T1 minus T2 is 0.5 x double dot, right. Putting the T1s and T2s in there then, and using the room on the left hand side here, we get 2/7 into 3 minus 10x minus 2/7 into 3 plus 10x equals 0.5 x double dot. Okay, we're well on the way now. You can see that the 2 times 3/7 cancels out, and we get down to 0.5 x double dot equals minus 40/7 times x. Nearly there. That says the acceleration x double dot is minus 80/7x. That's SHM, because it's of the right form. Acceleration at x double dot is minus omega squared x, and omega squared we can identify now is 80/7. So, to use up some room up here, let me just draw a bit of a line across there like that, and down, and carry on here then. So, period for the SHM, t equals 2 pi over omega, and that gives us 2 pi root 7 over 80. That's what it'll be. 2 pi square root of 7 over 80. That's the time period. Vmax, the greatest speed. Well, the greatest speed in SHM is a omega, and it happens at the center. Now, in this question, if you haven't made notes or printed it off, you'll need to go back to the wording of at the very start of the question. We know the amplitude because it was released from a point 0.2 meters from the center. 0.2 meters. So Vmax equals a omega, a equals 0.2. So Vmax equals 0.2 times square root of 80/7. Okay, that gives us the maximum velocity. Pardon me for croaking. The greatest speed then. Okay, that's part D done. What's left? Right, just one more part. And it refers to a point D lying between O and A, where OD is 0.1 meters. Okay. Now, just draw a quick diagram for that. O was at the center of the string. A was the left-hand side. X was measured to the right of O before. D is between O and A, so D is here, where OD is 0.1. So OD is where X equals not plus 0.1 but minus 0.1. Because remember, it starts off at C here, at the amplitude, which is 0.2 away from the center. Okay, so OD is where X equals minus 0.1, and the equation is X equals A cos omega t, because we're starting from the amplitude, and we can put a bit more information into that. It's X equals 0.2 cos root 80/7 t. So the time to reach X is minus 1 then. Minus 0.1, beg your pardon. We've got minus 0.1 equals 0.2 cos of root of 80/7 t. Simple little trig equation. Well, not a bad trig equation to solve then. So minus a half is cos of root 80/7 t is minus a half. That tells us that the angle there then is 2 pi over 3. Take a minute to pause the video and just check that if you like. And then from that we get t. T equals 0.6195 or 0.62 seconds to 2 decimal places. Or if you want it in square roots, again you can check this, it's t equals pi over 3 square root of 7 over 20. But they're quite happy to accept decimals. Okay, for the marks then. Going back to, let's see, it's been a bit slow. That's parts C and D, well, parts A and B. Right, that's parts A and B then. For the marks for that, we've got an M1 for the tension in AP, BP and the tension in AP. We had an M1 and an A1 and an A1. 3 marks for that. 2 marks for part A and 1 mark for part B. Going on. Carrying on from that. To show it performs SHM, we had a total of 6 marks. Well, there was an M1A1 for this equation here. And then for simplifying that and getting down to x double dot is minus 80 over 7x, there was M1A1, and therefore getting omega squared from it. For getting t, the time period, by quoting the formula and putting the correct value in, M1A1 for that. And that's the 6 marks for the proving SHM and proving the time period. And for the greatest speed, 2 marks, well, just an M1A1 for this. Okay. And for the very last part, part E, 4 marks for that, I think. Yeah, 4 marks for that. M1 for quoting x equals 0.2 for quoting this. A1 for putting the minus 0.1 in. And M1 for then solving that trig equation and getting that, and then getting the correct answer there. That's the 4 marks for that. 2 method marks, 2 accuracy marks. And that concludes the June 2011 paper. Thanks for listening. Hope it was useful.